Many consider Yann LeCun as the father of machine-based OCR, or optical character recognition, which is the forerunner of the pattern recognition technology at the core of AI-based deep learning. After occupying prestigious positions at Bell Laboratories, AT&T, and NYU, LeCun was hired by Facebook in 2013 to head up their AI research division known as FAIR, Facebook Artificial Intelligence Research. Facebook, along with tech giants like Microsoft, IBM, and Google, are sparing no expense in this area as new and enhanced versions of AI have proven superior at picking up skills to better challenge machine deep learning processes than their human counterpart engineers. The engineering and programming side of this challenge has always been centered around devising machine-based neural networks that mimic biological-based brain functions by building intricate replicas of the brain using artificial biosystems to construct inorganic-based neural networks. That challenge appears to have been met. Numenta, a Silicon Valley startup, is focused on understanding and exploiting principles behind how human wetware works to replicate it in machines running artificial general intelligence. Vast databases, or data dumps, are required in order to teach AI to learn in a manner similar to human mind through a machine reasoning process known as deep learning. Deep learning, unlike mathematical-based algorithms, is dependent on a process of pattern recognition, a biological function performed by the human brain. AI software engineers have been baffled regarding the roles played by the thousands of synapses connected to each biological neuron in the overall human reasoning process, which change and adapt as learning progresses by way of a type of electrical pattern recognition. Until now. AI software engineers at Numenta have discovered that proximal and distal synapses actually perform different functions and that the distal synapses act as pattern differentiators in thousands of electrical signals or patterns being transmitted on a biological neural network. This allows the synapses to not only recognize the presence of a particular electrical pattern, but to predict or learn the sequence in which the pattern will appear. This provides not only the basis for brain learning, but also the basis for learning recall. Engineers have also determined that it is not electrical patterns themselves that are key to rapid identification, but the differences in those patterns that are actually key to the patterns themselves. For example, the information content required by the human brain to recognize a word, which can have images and associations attached to it, is much greater than the information content associated with a number, which say has no image association connected to it, as in and of itself its value is finite. The process by which the human brain utilizes thousands of synapses connected by even more proximal and distal dendrites has been an obstacle to creating AI machines to mimic the learning process of biological brains using pattern recognition. The pursuit is on to create artificial neurons with a single point processing capability versus the distributed, decentralized processing model employed by the natural biological wetware we call our brains. LeCun is aiming for something much more sophisticated than his pattern recognition software for AI. At Facebook, he's pioneering artificial general intelligence deep learning technology that will provide both the common sense and communication skills necessary to converse with machines using voice alone, whereby the machines are capable of understanding sentences, express communication clarification, and make suggestions and recommendations to its human interface. LeCun goes on to explain that machines with these capabilities may eventually know what's better for us than we do.